So continuing on from these definitions, I want to go ahead and do an example. So here's an example. And this is an example that would be in the context of the circle. Or we'll think of it in the context of the circle. So the question says, if we have an angle theta between 0 and pi over 2, and cosine theta is 1/3, can we find the following? Can we find secant theta? Can we find cosecant theta? And can we find cotangent theta? So we want to find the value for each one of our reciprocal trig functions. And we know the value of cosine, and we know the location, right? So this is quad 1 here. So we want to find these. Well, we can just use the definitions, right? So we want to use the definitions. So we know that secant theta is 1 over cosine theta, right? Whatever cosine theta is. But then we know cosine theta. Cosine theta is 1/3. So we have 1 over 1/3. And this is a fraction of a fraction, which is something that confuses people a lot. So just to be clear, the property for this is if you have a fraction a over b over c over d, what you do is you keep the top fraction the same. So a over b is the same. And then you flip the bottom. So the bottom is c over d. We flip that, so it's d over c now. And we just multiply. So this is a times d over b times c. Right, so this is fraction of fractions. So this top fraction is 1 over 1. So this is 1 times 1/3 upside down is 3 over 1. 1 times 3 over 1, this is just 3. So secant theta is 3 if cosine is 1/3. Next up, we have cosecant. So cosecant, we know from the definition, is 1 over sine theta. However, we do not know at the moment what sine theta is, right? So we don't know sine theta. So don't know sine theta yet. However, we can figure it out, right? We know if we know the value of cosine, we can always figure out the value of sine by using the Pythagorean theorem. We also know about the location. So quad 1, sine is going to be positive, right? Because sine is the y-coordinate. So y-coordinate is positive. So therefore, sine theta is going to be positive, right? So that's what this tells us. So we know it's going to be positive, and we can find it by using this. So we know that cosine squared theta plus sine squared theta has to be 1. That's an identity. Cosine theta is 1/3. And so 1/3 squared is 1/9. Sine squared theta equals 1. We solve for sine, right? So sine theta is going to be square root of 9 over 9 minus 1. That's 8 over 9. Now, 9's a perfect square. That's a 3. And root 8 is the same as root of 4 times 2. Wiley would like you to break your answer up in pieces. So 8 is equal to 4 times 2, and then 4 is a perfect square as well. So square root of 4 is 2. So that breaks off. You get a 2. Square root of 2 can't be simplified anymore. And the bottom you get 3. And we choose positive because we know the quadrant location. And so we have to go back now. cosecant theta is what we want. Cosecant theta, 1 over sine theta, which is 1 over 2 root 2 over 3, fraction of a fraction. Bottom fraction flips. So this is 3 over 2 root 2. Now Wiley would like you to rationalize this, so we don't want any square roots in the denominator. So we multiply by root 2 over root 2, which is the same as multiplying by 1, doesn't change anything. The top is 3 times root 2. No way to simplify that. Root 2 times root 2 is root 2 squared, right? And then root squared undoes the root, and we just get 2. So then there's this 2 times these two root 2's gives us 2 times 2, and so our final answer is 3 root 2 over 4. That is the value of cosecant theta. So a little bit involved on that one because we don't know sine. So secant, cosecant, we're just using the definitions. Finally, cotangent. Well, cotangent is tangent 1 over tangent, right? So it's a reciprocal of tangent. But there's another way to think about this. We know that tangent is sine over cosine. So this is 1 over sine over cosine. Fraction of a fraction, bottom flips. And so cotangent is actually tangent upside down. It's cosine over sine, right? So this is tangent upside down. That's literally what this is here. So tangent upside down. Why do I mention that? Well, the reason I mention that is because we have cosine and sine. Well, we either have those or we just figured it out, right? Cosine is a third, that was given. So we have a third on top. And then sine, we just figured out over here, sine is 2 root 2 over 3. So we get 2 root 2 over 3. Fraction of a fraction, top fraction stays the same. So that 1/3 is like that. Bottom fraction, flip it, right? 3 over 2 root 2. 3's cancel. We get 1 over 2 root 2. And again, rationalize the denominator. We end up with root 2 over 4. And that is the value of cotangent. So cotangent is root 2 over 4. So yeah, if we are given the value of cosine or sine, we can find the other. And then if we're trying to find the reciprocal trig functions, we literally just use the definitions, right? So the definitions that we have from the previous video, we just literally use these definitions. You go back to cosine and sine, the things we're comfortable with working with, and we can find these values. So there's a homework problem like that, so it would be wise to try that after watching this video.